Good morning, everyone. This is Venugopal, lecturer in chemistry. Okay. Here, today we are going to discuss about the topic is hybridization. Hybridization. Okay. So, for example, Sp3 hybridization of carbon. Sp3 hybridization of carbon. Sp3 hybridization of carbon. In this hybridization, the best example is methane. Methane. So, Entama, methane is the example of the sp3 hybridization which is exhibited by the carbon. So, here in this methane, the central atom is what is the central atom? Central atom, here it is carbon. So, what is the atomic number of the carbon? Sir, any atomic number? Atomic number which is equal to 6. So, what is the electronic configuration of carbon? Here, for carbon we have 1s2, 2s2, 2px1, 2py1 and 2pz0. Here, the orbital representation of the Valency shell, sir, which is called Valency shell. Here, Valency shell means what? Enti Valency shell ante the number of electrons which are present in the Valency shell. The number of electrons which are present in the outermost shell. For example, here this is the nucleus of the carbon and this is first orbit, that is n is equal to 1, principal quantum number of which is equal to 1. In this first orbit we have 1s2 is the electronic configuration and second orbit, that is principal quantum number which is equal to 2. Then it is said to be n is equal to 2. What is the electronic configuration, sir? 2s2, 2p2 is the electronic configuration which is present in the second orbit. Which is present in the second orbit. 2s2, 2p2. With respect to E nucleus to man chusinapudu, here this is said to be what? Outermost shell. Valency shell. The electrons which are present in the Valency shell which are called valence electrons. Valence electrons. So that's why this Valency shell containing 2 electrons in a 2s subshell and 2 electrons in 2p subshell. The orbital representation of the carbon will be in its ground state. We can write like this: 2s2, 2px1, 2py1, 2pz0. So 2s2, there are 3 set of 2p orbitals, right? 2px1, 2py1 and there is a vacant 2pz orbital. Vacant 2pz orbital. So there is a theory like that. Number of unpaired electrons which are equal to the number of covalent bonds. Ante kada sir? Covalent bond can form by the sharing of electrons. Covalent bond formation takes place by the sharing of electrons. Mutual sharing of electrons. In our hydrogen molecule, we can say in our hydrogen molecule, each hydrogen can donate 1 electron to the for the formation of bond formation. So that's why there is a formation of H2 molecule by the each electron of the hydrogen atom can participating in the bond formation. So like that, here number of unpaired electrons only the criteria for the bond formation. Right, sir? So here total number of unpaired electrons in carbon's ground state electron configuration, there are only 2 unpaired electrons. So there is a formation of such number of covalent bonds which are equal to the 2 only. So number of unpaired electrons. Any unpaired electrons unte and covalent bonds formation jarugutundi. So here there are only 2 unpaired electrons are present. So that's why there is a possibility for the formation of 2 covalent bonds only. Right, sir? But according to our experimental studies, okay, we know that the carbon, which is in organic chemistry, carbon containing at least 1 carbon, there is a formation of molecule like that methane only. Ante carbon with 4 hydrogens మాత్రమే. ఓకేనా, అది at least గా ఉన్నటువంటి ఆర్గానిక్ మాలిక్యూల్ చెప్తాను. సో కార్బన్ విత్ 4 హైడ్రోజన్స్ అనేది పాసిబిలిటీ అవుతుంది. బట్ దేర్ ఈస్ ఓన్లీ 2 అన్పేర్డ్ ఎలక్ట్రాన్స్. మరి ఇది ఎలా అని అంటే, హియర్ there is a chance for the shifting of electron from the lower energy state to the higher energy state. So ఇక్కడ మనం ఏం చెప్తామంటే కార్బన్ ఇన్ ఇట్స్ ఎగ్జైటెడ్ స్టేట్. Sir, carbon which is in the excited state, this lower energy electron may jump into the higher energy 2pz orbital. So by the absorption of energy in the form of heat energy or light energy. So in the form of light energy or heat energy, the carbon can undergo into the excited state for the formation of 2s1, because this electron may jump into the higher energy 2pz orbital for the formation of 2px1, 2py1, 2pz1. So here 2s1, 2s1, 2px1, 2py1, 2pz1. So this property also explained on the energy level diagram also. We can see like this. Here this is the energy. Sir, carbon at ground state, right? So what is the electron configuration? 2s2, 2p orbitals. In this 2p orbitals, 2s2 is the electronic configuration, 2p2. And carbon which is in a excited state. So here promotion of electron can take place from lower energy level to the higher energy level by the absorption of energy in the form of heat energy or light energy. So for example, here what is the electron configuration? 2s1 and 2p3 is the electronic configuration. So each 2p orbital can acquiring, you can separate like this. Yes, so 2p3 is the electronic configuration. Now there is another question can be arised. Sir, here there is a availability of number of unpaired electrons, 1 electron in 2s subshell and 3 electrons in the 2p subshell. So bond formation ela jarugutundi. Okay, we can see how the bond formation can take place. Here in this carbon there are 3 unpaired electrons in the 2p subshell and 1 unpaired electron in the 2s subshell. We know that 2p orbitals are dumbbell like shape, right? What is the shape of the px orbital? That will be For example, this is x-axis, 2px, and 2py, and 2p z-axis antunte there will be 2pz. So these three p orbitals which are perpendicular to each other, what is the angle between them? That is 90 degrees. 90 degrees is the angle. So ఇక్కడ మనం ఏం చెప్పొచ్చు అంటే they are going to overlapping with the s orbital of the hydrogen atom. For the formation of, there is a rectangles to each other, and there is the presence of 2s subshell which is a directionless. Okay, 2s orbital ఎలా ఉంటుందండి, spherical in shape, but there is no particular direction. So our spectroscopic studies tells that ఏమని చెప్తుంది అంటే here 2px, 2py, 2pz, these three are perpendicular to each other, and 2s is non-directional. ఒక particular direction అంటూ ఏది లేదు. But in methane మనకి ఎలా వస్తుందమ్మా అంటే there is a presence of only same type of carbon bond hydrogen bonds are present. Carbon bond hydrogen bonds are present. So these four carbon bond hydrogen bonds which are similar, which are equivalent అని చెప్తున్నారు. అంటే here there is a ఒక కన్క్లూషన్ ఏంటంటే అండి, ఇక్కడ 2p ఆర్బిటల్స్ ఉన్నాయి. 2p ఆర్బిటల్స్ క్లియర్లీ దే ఆర్ హయ్యర్ ఇన్ ఎనర్జీ అండ్ దేర్ షేప్స్ ఆర్ డంబెల్ ఇన్ షేప్. ఓకే, అలాగే 2s orbital which is a spherical in shape and it is in the lower in the energy. So ఇక్కడ 4 equivalent carbon bond hydrogen bonds formation ఎలా జరుగుతుంది, what is the chance అని అడిగితే here these 2s orbital and 2p orbitals they are going to intermixing with each other for the formation of hybridized orbitals. సో ఇక్కడ న్యూ కాన్సెప్ట్ అనేది ఇంట్రొడ్యూస్ అవుతుంది. ఏంటది అని అంటే here the pure 2s orbital and pure 2p orbitals they are going to mixing with each other for the formation of new set of orbitals which are equal in energy and equal in shape containing orbitals which are called hybridized orbitals. Which are called what? Hybridized orbitals. So ఇక్కడ 2s అనేది లోయర్ ఎనర్జీ, 2p అనేది హైయర్ ఎనర్జీ అనే డిఫరెన్స్ ఏమి ఉండదు ఎక్కడ అంటే హైబ్రిడైజ్డ్ స్టేట్ లో. సో కార్బన్ which is in hybridized state, we can write like this 2sp3 because involvement of one s orbital and involvement of the 3p orbitals, there is a formation of sp3 hybridized orbitals. So sp3 1 and 2sp3 1, 2sp3 1, 2sp3 1. So there are 4 set of orbitals which are all are equal in energy and equal in shape containing hybridized orbitals. So what is the shape of the hybridized orbital? What is the shape of the hybridized orbital? Which contains a big loop as well as a small loop in its shape. Okay na? ఎలా వస్తుంది, intermixing of s orbital and intermixing of p orbitals can takes place. So for the formation of equivalent orbitals which are called hybridized orbitals containing one is with a big loop and one is with smaller loop. So in this hybridized orbitals, here in this hybridized state we have each orbital containing with a one unpaired electron. So that's why each orbital with one unpaired electron can takes place. We can see this in the form of energy level diagram also. Here lower energy 2s orbital and higher energy 2p orbital, they are going to mixing with each other for the formation of equal in energy. All are degenerate orbitals. So what is mean by degeneracy? Here same energy containing one. These are all sp3 hybridized orbitals, each orbital containing one unpaired electron. And so which are all are equal in energy and equal in shape containing hybridized orbitals, which are called hybridized orbitals, and the phenomena which is called hybridization. What is our topic? Hybridization. So what is the definition of the hybridization? The intermixing of pure orbitals for the formation of equal in energy, equal in shape containing orbitals. Okay sir? And ఇంకా ఒక జనరల్ ఎగ్జాంపుల్ తీసుకోవచ్చాడు, చూద్దాం. ఫర్ ఎగ్జాంపుల్ ఒక ఇంట్లో ఈ శ్రావణ మాసంలో మామూలుగా పెళ్ళిళ్ళు అవుతున్నాయి కదా. ఇట్లా పెళ్ళిళ్ళు అవుతున్నప్పుడు ఒక తనకి ఇద్దరు కూతురు ఉన్నారనమాట. సో పెద్ద అమ్మాయి పెళ్ళి కుదిరింది. సో దట్ ఏమవుతుంది, ఇంట్లో పెయింట్ వేస్తారు కదా సార్, వేసినప్పుడు వాళ్ళ నాన్న ఏం చేశారంటే అంతా కూడా ఓన్లీ వైట్ పెయింట్ తీసుకొచ్చారు. సో వీ కెన్ సే వైట్ పెయింట్ అనేది మొత్తం తీసుకొచ్చారు. సో తీసుకొచ్చేసి రూమ్స్ అన్నిటికీ పెయింట్ వేయడం స్టార్ట్ చేశారు. అట్లా స్టార్ట్ చేసినప్పుడు వాళ్ళ చిన్న అమ్మాయి ఆయనతో పరిగెత్తుకొని వచ్చి వాళ్ళ ఫాదర్ దగ్గరికి వచ్చింది. వచ్చి ఏంటి నాన్న నువ్వు ఇట్లా చేసినావు అని అన్నాడు. నేనేం చేస్తానమ్మా అని వాళ్ళ నాన్న అన్నాడు. లేదు మొత్తం అన్ని రూమ్లకు వైట్ పెయింట్ వేయించినావు, నాకు అంత నచ్చలేదు, నా రూమ్లో బేబీ పింక్ పెయింట్ కావాలి అని అడిగింది. అడిగేసరికి అతను ఏం చేశాడు, అరే నేను తెచ్చినటువంటి నంబర్ ఆఫ్ టిన్స్ ఏవైతే ఉన్నాయో అవన్నీ కూడా ఓన్లీ వైట్ పెయింటే తెచ్చినావు, ఇప్పటికిప్పుడు పింక్ కలర్ కావాలంటే ఎట్లా వస్తుంది అని అతను పాపం టెన్షన్ అయిపోయాడు. అయిపోయినప్పుడు అక్కడే పక్కన ఉన్నటువంటి పెయింటర్ ఏమని చెప్పిండంటే, సార్ మీరు వరీ కాకండి, ఓకే దిస్ ఇస్ అ సొల్యూషన్ లైక్ దట్. ఏంటి అని అంటే, సార్ మనము ఒక 10 ఆఫ్ రెడ్ పెయింట్ తీసుకుంటే దానికి 1:3 రేషియోలో, అంటే ఒక టిన్ రెడ్ పెయింట్ 3 టిన్స్ ఆఫ్ వైట్ పెయింట్ మనం యాడ్ చేసినట్లయితే మనకు కావాల్సినటువంటి బేబీ పింక్ కలర్ అనేది రావడం జరుగుతుంది సార్ అని చెప్పేసి ఆ పెయింటర్ చెప్పాడు. అంటే ఇంటర్మిక్సింగ్ ఆఫ్ 1 రెడ్ పెయింట్ విత్ 3 రేషియో ఆఫ్ ది 1:3 రేషియోలో, ఓకే 3 ఆర్బిటల్స్, ఇక్కడ మనం ఆర్బిటల్స్ అంటున్నాం, అక్కడ పెయింట్ అని చెప్తున్నాం. సో 3 టిన్స్ ఆఫ్ వైట్ పెయింట్, ఇక్కడ 1 టిన్ ఆఫ్ రెడ్ పెయింట్ అనమాట. సో ఇంటర్మిక్సింగ్ టుగెదర్ ఫర్ ద ఫార్మేషన్ ఆఫ్ 4 ఈక్వలెంట్ హైబ్రిడైజ్డ్ ఆర్బిటల్స్. అక్కడ మనకి బేబీ పింక్ కలర్ వస్తుంది, ఇక్కడ వచ్చేసి మనకి హైబ్రిడైజ్డ్ ఆర్బిటల్స్ అనేది ఫార్మేషన్ జరుగుతుంది. సో హియర్ లైక్ దట్ we can get the shape of the orbital that will be, sir, they are arranged. So in this hybridized state they are arranged, hybridized orbitals in the form of corners of the regular tetrahedron. So what is the shape of the methane molecule? Means shape of the methane molecule that will be regular tetrahedron. So each orbital containing one unpaired electron, each orbital containing one unpaired electron. So they are going to bonding with the hydrogen. So what is the hybridization of the that is electronic configuration of hydrogen means 1s1. So s orbital containing one unpaired electron in the hydrogen. So here shape of the s orbital is spherical in shape. They are going to overlapping with the sp3 hybridized orbital of the carbon for the formation of sigma bond. Sigma bond formation can takes place by the end to end overlapping, otherwise head on overlapping అని చెప్తాం. So here there is a formation of hydrogens s orbital and sp3 hybridized orbital of the carbon. So like that there is a formation of sigma bond can takes place like this. Total number of bonds which are equal to 4. There is a formation of 4 sigma bonds, right sir? So what is the shape? We can draw like this: carbon with the 4 bonds which are all are equal in energy. Okay, same bond length untundi, as well as in between any 2 bonds the bond angle will be 109 degrees 0.28 minutes ga untundi. Okay, here 109 degrees 0.28 minutes. So shape of the molecule which is known as tetrahedron. Tetrahedron is the shape of the methane molecule. Sir, in methane, what is the ground state electronic configuration of carbon? That is 1s2, 2s2, 2px1, 2py1, 2pz0. Here, Valency shell, the shell which is present outermost to the nucleus, which is called Valency shell. Okay, in this Valency shell, how many number of electrons are present? So those are said to be valence electrons. Okay, these valence electrons are only the criteria for the formation of bond. Okay, here total number of bonds number of unpaired electrons which are equal to the 2 only. So that's why మనం ఏమనుకుంటున్నాం, there is a possibility of only 2 unpaired electrons ఉన్నాయి కాబట్టి there is a possibility for the formation of 2 covalent bonds only. But in its excited state, okay, carbon's excited state, by the absorption of heat energy, otherwise absorption of light energy, one electron from lower energy level to the higher energy level can jump takes place for the formation of 2s1 and 2p3 is the electronic configuration. But the energy is different as well as shapes of the orbitals also different. So 2p is clearly higher energetic than that of the 2s, and 2p contains dumbbell in shape, 2s contain non-directional spherical in shape. So that's why there is no chance for the formation of the equivalent bonds. So here మనకి ఇక్కడ వచ్చి చూడండి, ఇట్లా ఈక్వలెంట్ బాండ్స్ రావడానికి ఛాన్సెస్ లేవు, because their energy as well as their shapes are also different. So that's why they are going to intermixing with each other. They are going to intermixing with each other for the formation of equal in energy and equal in shape containing hybridized orbitals, each orbital containing with at least one unpaired electron. Then there is a formation of molecule like this. There are 4 equivalent sigma bonds which are by the overlapping of s orbital of the hydrogen atom and sp3 hybridized orbital of the carbon atom can takes place. There are possibility of 4 bonds which are equally separated by the 109 degrees 0.28 minutes, and the shape of the molecule that will be the tetrahedron. Thank you. బ్రైట్నెస్ తగ్గుతుంది అది.